Existing memory-augmented multimodal large language models, or MLLMs, struggle with complex reasoning tasks. They often exhibit what we call brevity bias, where they tend to forget crucial details from past interactions. More importantly, they don't effectively integrate different modalities, specifically visual and logical information. This leads to two key problems: visual distraction errors, where irrelevant visual cues mislead the agent, and logical hallucination errors, where the agent makes incorrect logical deductions. The core idea behind ViLoMem is to explicitly separate and manage visual and logical knowledge within a dual-stream memory architecture. We hypothesize that by isolating the sources of error, we can develop targeted retrieval and refinement strategies to improve the agent's overall reasoning performance. It's about acknowledging that visual and logical processing are distinct cognitive processes and should be handled accordingly within the agent's memory system. ViLoMem employs a grow and refine approach. It has two separate memory streams, a visual memory and a logical memory. The visual memory stores image features extracted from past observations, while the logical memory stores structured logical statements derived from the environment. The grow phase involves accumulating new knowledge into these streams. The refine phase focuses on updating and correcting existing memories based on new experiences. Crucially, when retrieving information, ViLoMem uses question-aware attention masks for visual images to filter out distractions, and at precise positioning a precise selection regime for logical retrieval to ensure logical consistency. Let's dive into the retrieval. For visuals, we use attention mechanisms conditioned on the query. Imagine the query is "where is the red ball?" The attention mechanism focuses on regions in the visual memory most relevant to red and ball, suppressing irrelevant features. For logical retrieval, the precise positioning and precise selection method is key. It uses the query to identify specific locations in the knowledge graph corresponding to the question, then selects only the most relevant and consistent logical statements at those locations. The paper demonstrates ViLoMem's effectiveness on 6 multimodal benchmarks. It consistently improves pass-at-1 accuracy, meaning the agent gets the correct answer more often on its first try. More importantly, it substantially reduces the occurrence of repeated visual and logical errors. Ablation studies further validate the importance of the dual-stream memory and the error-aware refinement process. This research is a significant step towards building more robust and reliable multimodal agents capable of lifelong learning and adapting to new environments without catastrophic forgetting.